yesterday, we were looking with the unit circle, and we focused in on quadrant 1. And the whole point of the unit circle was how trig is defined, that if we have some angle measure that emanates from the origin, now I'm going to say this is about 30 degrees, some angle will intersect the circle. Some angle will intersect the circle. We want to be able to find that coordinate. So the angle, 0 degrees, intersects the circle. 30 degrees intersects the circle. If we've got 45 degrees, we have some coordinate. 60 degrees. Each of these, there is some coordinate where that angle would intersect the unit circle. So 30 degrees, we've got 45 degrees, we've got 60 degrees, so forth. Now those angles came about because those were our special right triangles. 30, 60, 90, 45, 45, 90. Well, 0 degrees, 90 degrees we could work with. Putting it back on the board from yesterday. What was the coordinate right at 0 degrees? That is 1, 0. Coordinate at 90 degrees. We have 0, 1. 30 degrees. 30 degrees. We didn't do 30? Oh, sorry. Well, 30 degrees. How did we find 45 degrees or 60 degrees? It's cosine, sine. If we take this, turn this into a right triangle. Turn this into a right triangle. Well, the coordinates, x unit over, y units up, that's x, that's y. We have a right triangle in there. And to restate, unit circle, how long is our hypotenuse? How long is our radius? 1. Well, relative to 30 degrees, adjacent is the x, adjacent hypotenuse, cosine of some angle. It's adjacent over hypotenuse, or adjacent over the radius. Since our radius is 1, cosine is always just the x value. Sine of an angle. Sine of an angle. Sine of 30 degrees. Opposite, hypotenuse. Well, that's going to be the y value over the radius. The radius is 1. It's just the y. And so we saw yesterday, we worked through with the 45, 60, but we can do the same thing. We've got root 3 over 2 is going to be the x. 1/2 is going to be the y. We got 45 degrees yesterday. Root 2 over 2. Root 2 over 2. We got 60 degrees yesterday. 60 degrees and 30 degrees are complementary. 1/2 root 3 over 2. Same thing, backwards. Yeah. So, we get any coordinate around there, given some angle. X is always our cosine, y is always our sine. X is cosine, y is sine. Remember that, alphabetical order. CS, X, Y, alphabetical order. So, if I ask you, what's the cosine of 30 degrees?
60.
Not even close. Throw the calculator away. It's right there. 30 degrees. Cosine is always the x value around the root unit circle. We've got root 3 over 2. How about 90 degrees? What's the cosine of 90 degrees?
Go with 1. Root 3
X. 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 Try again.
Root 1 over 1.
I'm pointing right at it. You cannot possibly get this wrong if you tried. 0. When we look at the triangle, when we look at the triangle, 0, the calculator says 0. It didn't really make sense, but here It's right there. It's the coordinate. What's the sine of 90 degrees?
1.
It's right there. It's the y value is 1. How about the tangent of 90 degrees? Tangent of 90 degrees. It's undefined. Back to when we plugged it into the calculator, it was undefined. Opposite over adjacent. We weren't so certain with the adjacent in a triangle. It didn't work out. So why does undefined make sense?
Because there's like 2 answers, right?
Yeah, but there were 2 answers on the triangle and we had cosine. So how does it...
It's like,
Well, 90 degrees is this.
oh, the slope is undefined. Yeah.
Oh, tangent's the slope. Why is it the slope?
Because I just don't know. You just say because you know.
Tangent's going to turn out to be the slope. Tangent's going to turn out to be the slope. Let's go to physics. Well, fortunately, this isn't really physics. Let's go to physics. We remember vectors in physics? Vectors have a magnitude and a direction. Let me build it up.
So many
It's not really infinity. Where says infinity inside? Depends. Vectors, back to physics. How did we find an angle of a vector back in physics? It was the inverse tan of y over x.
Oh, right, the inverse.
Y over x. When else have we seen y over x? What else in math has been y over x? Slope! Tangent! Oh! Let's go back to the circle. 30 degrees. Well, we did cosine. Let's take a moment. What's the tangent of 30 degrees? Something that we can find. If we look right here. If we look right here, tangent, SOHCAHTOA, opposite, adjacent, 30 degrees. Cody, be quiet. Nope. We've got opposite is the y value. Adjacent is the x value. It's y over x. Well, we know that. That's just 1/2 is the y value over the x value is root 3 over 2. Well, the 2's cancel, simplify out. We have 1 over root 3. And we can rationalize that. But the whole point, if we look, when we do have a triangle, it is y over x. So tangent in the circle, just like we had cosine and sine in the circle, cosine is x, sine is y. Tangent, we can say right here. Tangent of any angle is always going to be the y value over the x value. Well, the y value is always the sine. The x value is always the cosine. So tangent comes out to always be the sine divided by the cosine. You can either stick with me and try this and get something down, or the next 4 months are going to be horrible. This is going to last. And if it's going to be horrible, if you're making that choice, go out in the hallway. So look, tangent, sine over cosine. Tangent of 90 degrees. What's the sine of 90 degrees? It's written right above it. Is 1. What's the cosine of 90 degrees? It's 0. What's 1 divided by 0? There it's undefined. So we have something that makes sense, assuming we're following along and thinking. It's not that it could be, we don't know where the adjacent side is. Based upon the definition, it's right there. We would have 1 over 0, it's undefined. It just doesn't work. And if it's the slope, if it is slope, because y over x, what kind of line? How would you describe the line from 90 degrees? That's well, we would describe it as a vertical line. And a vertical line, what's the slope of a vertical line? There it is. It makes sense. It needs to make sense. We're not just arbitrarily giving something in there. So we've got sine, cosine, tangent determined, defined around the unit circle. Cosine is x, sine is y. For any area where an angle intersects a circle, tangent's going to be y over x. Now we've got quadrant 1. We've got quadrant 1. Let's do quadrant 2. It's acceptable. Let's take 120 degrees. No calculator. What's the coordinate where 120 degrees intersects the circle?
1/2 root 3 over 2.
It is going to be 1/2 root 3 over 2. And how'd you get that?
I looked at my little chart here.
I feel like that'd be negative. Is a negative one. I believe that would be a negative one.
Cody's, Matt, are you going to let him change your answer?
I think that's fair.
Change it?
Sure?
Make it negative 1/2?
Yep.
Well, we say that that's the same value as right here for the 60-degree angle. How does, well, we don't have right triangles 120 degrees, but, what was it? We go to our reference angles. Thanks. We go to our reference angles. If we make a right triangle here, how big is our reference angle? Our reference angle is 60 degrees. Our reference angle is 60 degrees. Well, 60 degrees, we've got the same exact triangle. Just why is this negative instead of positive? We're in quadrant 2. Same thing. Instead of moving right 1/2 up root 3 over 2, oh, we've gone backwards. 60-degree reference angle, we go back 1/2, negative 1/2, up root 3 over 2. So 120 degrees is the same reference angle, has the exact same values as 60 degrees. That was 1/2, root 3 over 2. That's why our reference angles are so important. And let's go around. If we continue the circle, as best as my ugly circle looks, there are other angles that have 60 degrees as reference angles. In quadrant 3, what angle has a 60-degree reference angle?
230.
More? That's 240 degrees. 240 degrees, 180 plus 60. So we can find that coordinate. It's the same 30, 60, 90. We would have, well, negative 1/2, negative root 3 over 2, because they are quadrant 3. Quadrant 4, the coordinate will be positive 1/2 and negative root 3 over 2.
How do you know it's the y value is negative?
How do we know the y value is negative?
Negative.
We are below
That makes sense.
positive, negative,
Wow. Okay,
negative, negative.
I have a lot going on.
Last thing. What's the angle measure? What's our angle measure?
300.
What is it?
300.
We've got 300 degrees.